Stoichiometry looks hard, but it's actually just a hidden shortcut. If you understand this idea, stoichiometry becomes the easiest chapter, the most important topic under some basic concepts of chemistry, stoichiometry. See today how we need to approach stoichiometry questions. First, what is stoichiometry first? Let us see. It deals with, stoichiometry deals with calculation of amounts of reactants, and products. It deals with the calculation of amount of reactants and products involved in a reaction. Overall stoichiometry meaning here, calculations based on chemical reactions. The important point here, it is valid. Stoichiometry valid only for balanced chemical reactions. Only for balanced chemical equations. If reaction is not balanced, you will get wrong answer. So every time we need to make sure before going for calculation whether reaction balanced or not, we need to check. If reaction is balanced, no need to worry, directly you can proceed with the calculation. So how we can interpret the reaction? For example, if I take a balanced chemical reaction, here 2H2 gas, O2 gas giving 2H2O, even it is gas. So how we can relate it? How we can relate? See, how you can read it? I can read like 2 moles of H2, 1 mole of O2, 2 moles of H2O. Or you can write 2 into Na molecules, or here Na molecules for O2, 2 into Na molecules for H2O. So anyway you can interpret giving reaction, either you can take in terms of moles or in terms of molecules. In simple terms, stoichiometry meaning here, quantitative relationship between reactants and products, or in simple terms, calculation of amounts of reactants and products by using balanced chemical reactions. Let us enter into the calculation part. See the first question here. What mass of CaO is formed by heating 50 grams of CaCO3 in air? 50 grams of CaCO3 in air. So how we need to calculate here? See, calcium carbonate solid form, upon reaction it gives CaO plus CO2. CaO plus CO2. Here it is given as 50 grams. 50 grams, and remember here molecular weight of CaCO3 given in the question, that is 100. So if I convert the 50 grams into moles, how? Given mass by molecular mass. So here what I am calculating, number of moles of CaCO3 is equal to given mass 50 by molecular weight 100. So overall here we are getting 1 by 2 moles. 1 by 2 moles. But here we need to find mass of CaO. How to find mass of CaO? Whenever they ask for calculation of mass, moles into molecular weight. Moles into molecular weight. Just a minute, here we calculated. Just a minute, here you see properly. Here we got 1 by 2 moles. According to question, what we can relate here, half 1 mole of CaCO3 can give 1 mole of CaO according to given question. So half mole of CaCO3 will give half mole of CaO. Half mole of CaO. Even molecular weight of CaO is equal to 56. Because here according to given equation, if there is 1 mole here, here also 1 mole. If it is half mole of CaCO3, half mole of CaO. But how we calculate mass here? So here you can calculate mass of CaO is equal to whatever moles. We know 1 mole of CaO mass is 56. Half mole of CaO mass, here you will get 28 grams. 28 grams is answer here. Simple question. No complexity. Next, moving further. If 1 mole of ethanol completely burns to form CO2 and H2O, mass of CO2 formed is about. Mass of CO2 formed is about. So here first we should frame reaction. Ethanol we know C2H5OH. Upon oxidation, it gives 2CO2 plus 3H2O. Upon oxidation, it is balanced chemical reaction. Reaction not given in the question, but we know combustion of ethanol gives CO2 and H2O only. It is balanced chemical reaction. It is already balanced. So here 1 mole of ethanol will give 2 moles of carbon dioxide. How? According to reaction. So now if 1 mole of ethanol, directly they asked only 1 mole of ethanol, carbon dioxide formed we need to find. So here 2 moles of CO2 obtained, then mass of CO2 is equal to 2 into what is molecular weight of CO2, that is 44. So which is 88 grams. Here carbon is 12, oxygen is 16. So by using which you can find molecular weight, 88 grams is answer. According to stoichiometric coefficient only they asked 1 mole of, as we know 1 mole of ethanol will give 2 moles of CO2. Same we did calculation here. If any doubt, pause the video, observe it and move further. Next, third question. What volume of CO2 at 0 degrees Celsius and 1 atm is formed by heating 200 grams of CaCO3? See the calculation part. What volume of CO2 at 0 degrees Celsius and 1 atm is formed by heating 200 grams CaCO3? So CaCO3, number of times we wrote equation. Upon heating, it forms CaO plus CO2 gas. 200 grams given. They are asking what volume of CO2 we need to find under given conditions. And remember here these are STP conditions. Are STP or NTP? We know all both are same. Only the unit difference already we studied in first lecture. Next, based on this, CaCO3 how many moles given? How many grams given? That is 200 grams. I am converting given weight into moles. CaCO3 molecular weight 100. So here it is 2 moles. 2 moles of CaCO3 formed. But here we know, here already we know 1 mole of CaCO3 will give 1 mole of CO2. So what we can write here, 2 moles of CaCO3. 2 moles of CaCO3 produce how many moles? 2 moles of CO2. 2 moles of CO2. That is, they are not asking about moles, they are asking about volume. But here we know one statement. What is that statement? 2 moles of CO2 meaning we know 1 mole of any gas at STP conditions occupy 22.4 liters. So 2 moles, 2 into 22.4 liters. 2 into 22.4 liters is equal to, so you can write here 44.8 liters at STP conditions. So answer here 44.8 liters. Simple. 1 mole of any gas occupy 22.4 liters. 2 moles 44.8 liters at STP. That's what we concluded. Easy question. Directly you can solve it. Next, moving further. First everyone observe question. KClO3 unbalanced reaction they gave. If in above reaction 5 moles of KClO3 was heated, then find moles of O2 produced on completion of reaction. on completion of reaction. So let us see. First we need to balance the reaction. Without balancing you should not do. Stoichiometry works only for balanced chemical reaction. KClO3, KCl plus O2, 2KClO3, 2KCl and 3O2. Here they mention 5 moles of KClO3 was heated, then find moles of O2 produced on complete combustion. If 2 moles of KClO3 taken, according to reaction, 3 moles of O2 produced. According to reaction. But here what we need to focus, they mentioned here 5 moles of KClO3 taken. If 5 moles of KClO3 taken, so how much amount? I can find moles of O2 produced. They are asking about find moles of O2 produced. So see here. So how we need to calculate? If 2 moles taken, 3 moles of O2 produced. If 5 moles of KClO3 taken, then here how many moles of oxygen produced? That's what overall question meaning here. Let us understand. So how to find? So here moles of oxygen, moles of O2 produced. So let us see here how to find it. So here 5 moles of KClO3 giving dash moles of O2. So directly what we can do here? In such cases, whichever diagonal to each other, you multiply those 5 into 3 by the one which is diagonal to question mark, you write as denominator. So which is 7.5 moles. Once again understand here, 2 moles of KClO3 giving 3 moles of O2 produced according to reaction, because see here 2 moles, 3 moles. 5 moles given in the question. How many moles of O2 produced? To calculate cross multiplication, those two value 5 into 3 cross multiply, the value that is diagonal to question mark write as denominator. Then you will get 7.5 moles as answer for the given question. Next question. So easy here question, directly you can solve it. Next moving to the topic that is limiting reagent. So till now only one reagent based we discussed. So limiting reagent. First of all, what is limiting reagent? See here. Limiting reagent is one or the reactant which is completely consumed. The reactant which is completely consumed during the reaction. Means during the reaction, the reactant that is completely utilized, or you can say which becomes zero after the reaction, is called limiting reagent. In short, we can consider it as LR also. Limiting reagent. Short, you can refer it as LR, limiting reagent. So here remember, limiting reagent decides product of the reaction. Limiting reagent decides product of the reaction. Limiting reagent decides the product of the reaction. See, general example I am giving here. General example for understanding. See here, general example. I am taking here 2000 marker writing units. Marker writing units plus 1000 marker caps. Writing units excluding caps. marker caps, just for general example. Without cap here, writing units only I am considering, here caps. 2000 marker writing units and then 1000 marker caps. If I ask one question, by using these two components, see writing unit meaning excluding cap. So to make full marker, we need to join one writing unit with one marker. So how many markers we can make by using this? So you can make here, even though 2000 marker writing units, 1000 marker caps available. So you can make here 1000 markers. You can make only 1000 markers. So after making 1000 markers, here 1000 writing units, 1000 writing units extra. 1000 writing units extra after making full marker, 1000 writing units extra, that is left. So here after making, here becomes 0. Becomes 0 after making 1000 markers. Okay. So now what we can conclude here, in this reaction limiting reagent is marker caps. Why? Which becomes 0 after the reaction is limiting reagent. You tell me which is deciding product now. I am considering it as product. Product deciding is right, marker caps, because only 1000 left. 1000 available, 2000 marker units extra available. Even though 2000 marker writing units available, you cannot make 2000 markers. Marker meaning one cap, one writing unit together. So here 2000 marker writing units available, but we cannot make 2000 markers because 1000 caps only available. That is limiting the reaction. Hence that decides the product formation. Product formation. But here how we calculate, how we identify the product, or you can say limiting reagent in a given reaction. How we identify? Let us take one example and observe it. I am taking here AA plus giving thing that CCDD. So here assume that Na moles available, here NB moles given. NB moles given. Na, or an easy way you take, instead of this complex example, you take simple example. 2p plus 5q is equal to, think that P2Q5. Here given in the question, given that 7 moles of P and 2 moles of Q given. It is given in the question. Given in question, think that. One reaction given, 2p plus 5q giving P2Q5. If 7 moles of P react with 2 moles of Q, find limiting reagent. Find limiting reagent. General logic you can apply. With general logic you can get answer here. But every time instead of applying logic, you can use simple method, trick to find answer. For P, what I am doing here, so here you can do for P. Now given moles you write here, given moles in question by stoichiometric coefficient. S is stoichiometric coefficient. Stoichiometric coefficient of P is 2. Stoichiometric coefficient of Q is 5. So here given moles 7 by 2. For Q I am writing given moles 2 by 5. Given moles 2 by 5. Once if you see the calculation, among these, here we are getting 3.5. Here you see 0.4. So among this lower value, you can say smaller value acts as limiting reagent. Hence here Q is limiting reagent. So what we need to do is trick to find limiting reagent. Given moles per stoichiometric coefficient you do for both the reactants, whichever reactant getting lower value for this ratio, smaller value acts as limiting reagent, smaller value for Q. That's why Q is limiting reagent. So we calculate overall product only by using limiting reagent here. I hope limiting reagent concept clear to you. To find limiting reagent, trick what we used here. For both the reactants, calculate the ratio given moles by stoichiometric coefficient. Whichever reactant getting lowest value for this ratio, that is acting as limiting reagent. We use only limiting reagent for the calculation purpose. Next, see the question. Here 28 grams of lithium is mixed with 48 grams of lithium is mixed with 48 grams of O2 to react. 28 grams of lithium is mixed with 48 grams of O2 to react and reacts according to following reaction. They gave reaction also in the question. The mass of Li2O formed. They are asking about product. Mass of Li2O formed. Product amount they are asking. So if I write reaction here once again, 4Li plus O2 giving 2Li2O. So here first you calculate one ratio. Which ratio above I mentioned? How many moles of lithium giving? 28 grams of lithium given. I am calculating here moles of lithium, that is 28 by 7, which is 4. And moles of O2, 48 given, right? 48 by 32. Why 32? That is molar mass of O2 is 32. So here it is 1.5. So now given moles of lithium 4, given moles here 1.5. So let us calculate now. For lithium I am calculating given moles by stoichiometric coefficient, which is stoichiometric coefficient. For O2 given moles 1.5 by stoichiometric coefficient 1. Here value is 1.5, here value is 1. So among those, here it is smaller value. Here it is smaller value. We are getting here 1. So once if you know limiting reagent is, hence limiting reagent is Li. Once if you know limiting reagent is Li here, then calculate product according to. Then calculate product according to limiting reagent. So how to calculate? So here moles of LiO2 formed. So how we can do? According to reaction, see. According to reaction, if 4 moles of lithium giving 2 moles of Li2O, 4 moles of lithium giving 2 moles of Li2O, then how many moles given here? 4 moles only given. 2 moles of Li2O formed. So 4 moles of Li2O, so 2 moles of Li2O formed. But they are asking about mass. How to find mass here? See, molar mass, lithium mass is 7, oxygen is 16. So here molar mass of Li2O, so then mass of Li2O, how to find mass of Li2O? Moles into the molar mass of Li2O, which is 30 grams. Molar mass of Li2O. So overall 60 grams is answer. 60 grams is answer. See, what is here 30? It is molar mass. Molar mass of Li2O. Once if we get moles, you can multiply with molar mass to get mass. I'm repeating, if any doubt, you pause the video, observe thoroughly and move further. Next question. CaCO3 plus 2HCl giving to CaCl2 plus H2O plus CO2. 0.2 mole CaCO3 is reacted with 0.5 moles HCl. Find mass of CO2 produced. See the question. 0.2 moles of CaCO3 is reacted. Simple question. I am writing reaction once again. CaCO3 2HCl. First, you need to make sure that reaction whether balanced or not. Reaction is balanced. So now you see 0.2 moles of CaCO3 is reacted with 0.5 moles of HCl. To find limiting reagent, first what we need to do here? Find LR first. How we find LR? Given moles, how many moles? 0.2 by stoichiometric coefficient 1. 2 moles of HCl according to reaction, but given moles how many? 0.5 moles of HCl reacting with, that is stoichiometric coefficient 2. Here we are getting 0.2 in first case, and then followed by below one 0.25. So which is lower value? Here it is lowest value. So whichever is smaller value, that particular chemical substance acting as limiting reagent. Now by using limiting reagent concept, you have to calculate remaining question. So now you see 1 mole of CaCO3 can produce 1 mole of CO2. 1 mole of CaCO3 upon reaction can produce 1 mole of CO2. Here they are asking about CO2 produced mass. Okay, so 0.2 moles. 0.2 moles will produce how many moles of CO2? So it can produce, first you calculate moles, then you can convert into mass. So here it can produce 0.2 moles of CO2. 0.2 moles meaning how much amount of CO2 produced? Mass of CO2 is equal to 0.2 moles. Whenever to convert moles into mass, what you have to do? You have to multiply with molecular weight. Molecular weight is 44. If you are multiplying with molecular weight, then you will get answer for the given question. So how much you will get here? 8.8 grams. 8.8 grams is answer. How we got? Whenever after getting moles, just multiply moles with molecular weight so that you will get mass of the given substance. Next question. Observe question everyone. Maximum mass of C12H22O11 produced by mixing 84 grams of carbon, 12 grams of hydrogen, 56 liters of O2 at carbon, hydrogen, O2 reactions given. Sucrose we need to calculate. So how we need to do? Observe first question. You try to solve. Reaction already given. First to convert all substances into moles. 84 by 12 and then moles of hydrogen 12 by molecular mass 2. Here they get 56 liters of O2 at STP conditions. 56 liters of O2, here they mention even STP, at STP. We know volume at STP, that is 1 mole of any gas at STP occupy 22.4 liters. So to convert 56 liters into number of moles at STP, we can do this calculation. For example, if you are doing this calculation, in first case, here you get 7 moles, second case 6 moles, and then here third case here 2.5 moles. 2.5 moles. So now we need to find maximum mass of C12H22O11. For that, first find LR. Find LR. How to find LR? Given moles of carbon, how many? 7. In stoichiometric coefficient 1. Given moles of H2, how many? 6 moles, stoichiometric coefficient 1. Sorry, here reaction not balanced, right? So if reaction not balanced, you have to balance it. 12 carbons, oxygen. Observe the reaction. Reaction is not exactly balanced. So we need to balance it. 12 carbon. Hydrogens, how many you will get here? 11. Because 22 hydrogens and 11 oxygen atoms. So 11 oxygen atoms, what we do? To get 11 oxygen atoms, here they mention O2. We can do 22 by 2. Sorry. 11 by 2 oxygen atoms. 11 oxygen atoms. Balanced reaction. So carbon, here it is 7 by 12 stoichiometric coefficient. And then for hydrogen, 6 by 11. Then for oxygen, 2 by 5 moles by 11 by 2. 11 by 2. So first you calculate values here. Here 7 by 12 given, which is 0.58 according to given ratio value. And then 6 by 11 given, which is 0.54. Then here 11 by 2 moles. Yes, 11 by 2 here mentioned. So here you can mention, if you calculate, here you get 0.45 moles. So among these, lowest value, here there is lowest value, which is limiting reagent. Once again see calculation. See the calculation, LR is oxygen here. So based on this given LR, now we can proceed for the calculation of sucrose. They are asking here maximum mass of C12H22O11 produced. So now based on this, 11.2 moles O2 can produce 1 mole of C12H22O11. 1 mole of C12H22O11. So here even molecular weight here given, molecular weight of C12H22O11 is equal to 342. And then here 2.5 moles of O2 will give how many moles? Will give how many moles of sucrose? See question how they gave. First we need to find limiting reagent, then we have to proceed further to get answer. So what we need to do calculation here, how many moles you will get first. So here what we do to get calculation, here 2.5 into 1 by 11.2, you can say 11 by 2, which is equal to how much you will get? 0.45 moles. So then mass of C12H22O11 is equal to 0.45 into 342, which is equal to 155.45 grams. The final answer 155.45 grams. Once again see here, mass of C12H22O11 is equal to 0.45 into 342, 155.45. First step we identified moles. After that here moles identified, After that, limiting reagent. Based on limiting reagent, we proceeded further for the calculation. Okay, next. 1.5 grams of mixture of SiO2 and Fe2O3 and very strong heating leave a residue weighing 1.46 grams. The reaction responsible for loss of weight is given. What is percentage by mass of Fe2O3 in original sample? Percentage by mass of Fe2O3 in original sample. Like mixture based questions, these are. Mixture based questions. See now. What we need to do, see here. First I am writing here balanced reaction. 3 Fe2O3 plus 3 Fe3O3 plus half O2, balanced reaction. So now in question you see percentage by mass we need to find. Okay. 3 moles of Fe2O3 given here. Fe2O3 mass 160. Molecular weight of Fe2O3. Here Fe3O4. Fe3O4 it is. See properly here Fe3O4, and here molecular weight of Fe2O3. So molecular weight of Fe2O3, it is given in the question. How much it is given? It is given as 160. So 3 Fe2O3 plus Fe3O4, sorry, it is here you see properly 3 Fe2O3 giving 2 Fe3O4 plus half O2. So here in the question 3 moles of Fe2O3, 3 moles of Fe2O3 giving 2 moles of, sorry, half mole of, giving how many moles? Giving half mole of O2. If half mole of O2, okay, see 3 moles of Fe2O3 giving half mole of O2 according to given equation. So 3 moles of Fe2O3 meaning 3 into 160, molecular weight is 160, so it is 480 grams. 480 grams giving half into 32, which is 16 grams. So for 480 grams of Fe2O3, 480 grams of Fe2O3, 16 grams of O2 amount decreased, or you can say loss in mass. 16 grams of O2 amount decreased. Then, so what we need to find here? What is the percentage by mass of Fe2O3 in original sample? Loss of 16 grams for 480 grams of Fe2O3. So then what we can do here? Loss of 0.04 grams. 0.04 grams. Loss of 0.04 grams. If we consider here 0.04 into 480 by 16 will give 1.2 gram Fe2O3. Fe2O3. So 0.04 grams. See question how they mention. Observe it. 1.46 grams, leaving a residue weighing 1.46 grams. If 1.4, how we got loss of 0.04? Because they mention after the reaction residue, that is 1.46. So here how we got 1.5 minus 1.46, then the loss it is 0.04 grams. That's what we wrote. So by using which we can get information that 1.2 grams of Fe2O3 present in the given mixture. So then percentage by mass is equal to 1.2 by total mass how much? 1.5. 1.2 by total mass 1.5 into 100, which is 80%. Once again, see reaction first we wrote number of moles, based on that we convert into grams. 480 grams, 16 grams of O2 removed, and then here they mention 0.04 grams. Here decreased meaning amount, here lost, there is loss. 16 grams amount of O2 lost or removed for 480. And then for 0.04 grams, how much amount of Fe2O3 present? 1.2 grams we got. So overall percentage we can find 1.2 by 1.5 into 180%. So it is about some questions based on stoichiometry, but still topic not completed. The topic includes percentage purity, parallel reactions, sequential reactions, percentage yield, many topics, even idiometry. In next lecture, we are going to discuss all those topics. So stay tuned to the channel, properly observe these videos and solve the questions. Thank you. Thank you for your patient listening.